And this is the lesson for Friday 519, and this is the rest of 5.4. This is example 4, write as an algebraic expression. It might seem like a complicated problem at first, but as we kind of get into writing it, you'll see we're just following that process, and we'll also review kind of the arc trigonometric functions. Remember, the arc sine or the arc cosine means that they are giving you the ratio and you are going to have to find what the angle is. So this is number 4, and I'll write it down here. It says cosine of the arc sine of the square root of 3 over 2 plus the arc cosine, let me rewrite that, the arc cosine of x. And the directions say to write this as an algebraic expression of x that does not involve trigonometric functions. So really, you should be recognizing that this is the cosine of something minus of cosine of alpha minus beta, which equals the cosine alpha, cosine beta, plus sine alpha, sine beta. So our first job is just to write it out like that. And so that's what I'm going to do. If I can fit this, I might just make this a little smaller. And if I can fit this on one line, that's what I want to do, so I can write below there. So when I write this, it's just the cosine of the first stuff, cosine of the second stuff, minus sine. So it's the cosine of the arc sine of the square root of 3 over 2, cosine of the arc cosine of x. I wanted to fit this in this one line, but I don't think I'm going to, so I'll just move all this down here, I guess. And then since it's cosine, it'll be minus the sine of the arc sine of the square root of 3 over 2, the sine of the arc cosine of x. So first, it's just formulary, where we're just taking the cosine of alpha plus beta, which is the cosine of alpha, cosine of beta, minus the sine of alpha times the sine of beta. So as you're writing that, the yellow I'll get rid of in a moment, but you're just plugging that in to the formula that you know. The cosine of something plus something is the cosine of the first thing, cosine of the second thing, multiplied together, minus sine of the first thing, or sine of the second thing. Now, the next part of this is we have to kind of remember back to when we did these arc sine and arc cosine problems. So the arc sine of the square root of 3 over 2, I'm just going to kind of on the side here talk about that. The arc sine of the square root of 3 over 2. I don't know what the angle is, but there's some angle whose sine is the square root of 3 over 2. And I just want to make a triangle of that picture. I don't have to know what that angle is, although in this moment, that one I could know. So I'm going to call that just theta for a moment. And if there is some angle theta for which its sine is the square root of 3 over 2, sine is opposite over hypotenuse. So we could say this is the square root of 3, the hypotenuse is 2. And to find the other side, I can use the Pythagorean theorem. So this side is the square root of 2 squared minus the square root of 3 squared. And 2 squared is 4. Square root of 3 squared is 3. So this is the square root of 1, or just 1. And, you know, maybe you also know that that angle is it pi over 3? So that's fine, and we could do it that way, but I'm just doing it this way because I don't know this angle, and I'm never going to know this angle. So, so I want to kind of just think about it in that way. So if I want to find the cosine of this situation, that's how I'm going to say that. The cosine of this situation, well, cosine of theta is the adjacent over the hypotenuse. So the cosine of the arc sine of the square root of 3 over 2 is 1/2. Give me a head nod if you are with me that once I drew this picture, find the missing side, I know that the cosine of that angle is 1/2. Do you know that? Okay, and so then I'm also going to do, because this one kind of goes with it, oops, and this is to find the sine of this situation, which is the arc sine of the square root of 3 over 2. So the sine of this, here's the picture, the sine of that is just the square root of 3 over 2. So square root of 3 over 2. And I'll write the rest in. I'm just kind of finding that one little piece as I go. Then I'm not going to need this much space. So now I want to talk about just this arc cosine of x. So when I have the arc cosine of x, that means there is some angle whose cosine is equal to x. So I'll just draw another little triangle. I'll still call it theta. And since x I can think of as x over 1, that means the adjacent side could be x, the hypotenuse could be 1. And then I can get this missing side by saying it's the square root of 1 squared minus x squared. So the square root of 1 minus x squared, excuse me. And this can't be simplified anymore. That's just what that opposite side is. So now when I have this picture, and so it took me a little less to get that picture. When I have that picture, I want now the cosine of this situation. So the cosine of this situation is x over 1. So I'll put a times x over 1. I'll fill in my subtraction sign as well. And then the sine of this situation. So the sine of the arc cosine of x, the sine is opposite. Oops, I never put the right angle in there. Opposite over hypotenuse. So that is times the square root of 1 minus x squared all over 1. The hypotenuse is 1. So then this has reduced me to 1/2 times x minus 3 square root of 3 over 2 times the square root of 1 minus x squared. So I have right now gotten rid of all trig functions, and I have it just written that way. And then the next thing that I'm going to do is just look at these pairs and just multiply them together. So 1/2 times x over 1 is x over 2 minus, and I'll just write this one for now as the square root of 3 times the square root of 1 minus x squared over 2. And do you agree that things under the radical, because they're both square roots, things under the radical can be multiplied by things under the radical, right? And so I could just distribute that in as well. So I get x over 2 minus a big square root, 3 minus 3x squared all over 2. And since the denominators are the same, I can just write it as x minus the square root of 3 minus 3x squared over 2 for that problem. Now, I want to just kind of say what I'm doing here. So what I'm doing is first and foremost, I put this in the cosine sum formula. So I got that. And then I looked at each of these situations because they are arc sines. So I kind of had to set up a little picture to find my right triangle that I could use SOHCAHTOA with. And then I can find the cosine, which is that cosine out in front. And I can find the sine of that situation, and then the cosine and sine of that other situation as well. So that is getting rid of all of the trig functions. Now, the next thing that we have to do, there's two more kinds of problems. One is to verify some of the older things that are on your note card using these newer things that are on your note card. And then the other one is just solving an equation where we're having to expand things out. So here's our next couple problems are pretty straightforward if you remember this. So this is number 5, and I do have a couple of problems. 5 and 6 are kind of all these same kind of problems. So we want to verify that the cosine of negative theta equals the cosine of theta. So we can't just write it, you know, there it is, that is what it is. We want to show that one is equal to the other. And so the reason we're putting this one in our notes is so that it's going to give us a strategy. I can make this into a subtraction problem by saying that negative theta equals 0 minus theta. Do you agree with that? Yes. So anytime it's negative theta, I'm just going to make it 0 minus theta, and then I can use any of these subtraction formulas. So I'm going to say the cosine of negative theta is equal to the cosine of 0 minus theta. And then I'm just going to expand that out. Cosine of alpha minus beta is cosine alpha, cosine beta, plus, it uses the opposite sign, SIGN, sine alpha, sine beta. So then I'm going to expand this. So it's cosine 0, cosine theta, plus sine 0, sine theta. So I'm verifying that this is going to be the cosine x in the end here. And so then I can plug in values because I know values for those two. What is the cosine of 0? Cosine of 0, I go 0 to 1, and then I come back 0 to 1. So the cosine of 0 is 1. And cosine theta plus sine of 0. What's the sine of 0? Sine of 0 is 0, and then sine theta. So 0 times anything is 0, 1 times anything is that thing, so that gives us the cosine of theta. So we knew what the answer was going to be. The biggest challenge on these is just knowing to call negative theta 0 minus theta. And so you'll do that every time. Does that make sense? You'll just always do that and always put it in the formula as we go. So same thing here. This is the identity that tells these are cofunctions. And we do the exact same thing. Start with the left, use the big formula, and end up with the right. So for 6a, we're going to have the cosine of theta minus pi over 2 in parentheses equals the sine theta, and we have to verify that. So if we have to verify, you know, the good news is they're telling us the answer. It's just that now we have to use this new formula that we have. And they're doing a lot of cosines right now, so we are. So that should make things work out for ourselves. So maybe you're getting that pattern. This is like the 3rd time this hour we've written this one. So do you know it's going to be cosine theta, cosine pi over 2. And then since it was minus here, it'll be plus sine theta, sine pi over 2. The more you do these, the more they just kind of will seem a little easier because you're always doing the same pattern. And now cosine of pi over 2 and sine of pi over 2, I know what those are. What is the cosine of pi over 2? Say it again. 0. Cosine of pi over 2 is 0. So this is going to be cosine theta times 0 plus sine theta. What's the sine of pi over 2? 1 times 1. And so anything times 0 is 0. anything times 1 is that thing. So we get sine theta. And that's very straightforward. So if they ask you to do any of these kind of problems, like 5 and 6a, can you do those? Do you think you can do those? You know, just plugging that in and seeing what happens. So my question to you, and you're just going to help me decide right now, is do you want me to do this next problem that is the same kind of thing? I need to know right now. Yes, I'm seeing head nods, yes. So 6b, it is a tangent problem, so that makes it a little different. So the tangent of x minus 360, we want to show that that's equal to the tangent of x. So this is a good one to do just because it gives us a different formula. So the tangent of alpha minus beta is tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. There has to be two different adding and subtracting situations here, and tangent in the numerator, you start with whatever you were doing. So if it's minus, you'll minus, and then in the bottom there in the denominator, you'll add. So we start with the left. So tangent parentheses x minus 360 equals, and now I just put it in the formula. So it's tangent x minus tangent 360 all over 1 plus tangent x tangent 360. And you know we want to end up with tangent, so we know something should be, you know, kind of dropping out as we go through this. So tangent of 360, here's how I would think of that. You know, since it's not on my 0 to 90 table, I would kind of think though that really if I go 360, am I at 0 degrees? Yeah, so I can say that the tangent of 360 is equal to the tangent of 0. And what is the tangent of 0? What's the tangent of 0? 0. The tangent of 0 is 0. So when I have any place I have tangent of 360, I'm just going to replace that with 0. And generally, that's what's happening in these. You're replacing them with, you know, zeros and ones when you're doing these proving ones. Otherwise, they should be things that are on the table or can be found by the table. So tangent x minus 0 over 1 plus tangent x times 0. And so on the top, we just get tangent x. And on the bottom, tangent x times 0 is 0. So we just get 1. And so it's tangent x. Are you seeing the patterns kind of coming across on these? So the first problem, you know, that one, the first problem today was harder. I think when you go back and look at the ones we did yesterday, they're going to seem a little easier the more you see this pattern. Then the proving the identities are pretty straightforward. Then the last kind we want to do is to solve a trig equation. So find the solutions of this, and we are given an interval for this one. So when we have an interval, we just look in the quadrants, whatever we have to do, and we don't put plus 2 pi n or anything like that as we do that. So number 7 is sine parentheses x plus pi over 4 in parentheses minus sine parentheses x minus pi over 4 in parentheses equals 0. And I will just write up here the interval is from 0 to 2 pi. So it's a long problem. But are you noticing some similarities, right? You know, that we have the sine of x plus pi over 4 and the sine of x minus pi over 4. One little thing to be careful of, that subtraction in between those two big parts. We have to make sure that we're going to subtract all of that because remember, we're going to have more terms as we go. So the sine of alpha plus beta or the sine of alpha minus beta is always sine alpha cosine beta, and then whatever it was, plus or minus cosine alpha sine beta. So our first job is just expand everything out. So this first piece here is just sine x cosine pi over 4 plus cosine x sine pi over 4. So that's that chunk. And then here's the thing I have to be careful of. This subtraction sign here, I'm going to write it, and then I'm going to write a big bracket, because whatever this stuff is, I'll put it in blue. Whatever this is, I have to subtract all of it, and I'm going to have two terms now. So sine of parentheses x minus pi over 4 is sine x cosine pi over 4 minus cosine x sine pi over 4. And then I'll go back to red, close that, and set it equal to 0. Are you guessing some terms are going to drop out? Are you guessing that that's going to happen? Because it probably, it is. Now, the next thing I'm going to do is kind of clean these up a little bit. And do you agree cosine of pi over 4 is a fraction, right? Yes, sine of pi over 4 is a fraction. And so is it okay if I write that just in front and then the fraction and then sine x? Are you okay with me doing that? Yes or no? Is that all right with you? Yeah, yeah, okay. So when you look at your table, what is the cosine of pi over 4? Square root of 2 over 2. And what's the sine of pi over 4? We'll get them both in there. Same thing, yep. So I'm just going to rewrite these with the square root of 2 over 2 sine x plus the square root of 2 over 2 cosine x. And since that's pretty straightforward to us, can I also distribute this negative sign at the same time? Is that okay with you guys if I do that? So I'm going to write, this will be minus, and that's also the square root of 2 over 2 sine x. And this one, though, is minus a negative, so it becomes what? Plus. Plus square root of 2 over 2 cosine x. And so I like to get my fraction-y thing in front and then have my sine or cosine in the back. What happens here? I think good things happen. What happens? The sine x's cancel because it's square root of 2 over 2 sine, yep, and minus the square root of 2 over 2 sine x, that's 0. And then when I add these together, what is the square root of 2 over 2 cosine x plus the square root of 2 over 2 cosine x? It's 2 of those, correct? So it's like 2 square root of 2 over 2 cosine x's, I'll say it that way, equals 0. And so I can cancel those 2's. So it's the square root of 2 cosine x equals 0. And then we've solved these. So I'm going to divide by square root of 2 on both sides. So I get cosine of x equals 0. Now, I just want to say for the record that, maybe it would have been the square root of, or cosine x equals like the square root of 3 over 2, or equals 1/2, or equals, anything cosine could be on that table, right? Or positive or negative. So in this case, it just turns out that it's 0. And remember, the interval that we're working on is from 0 to 2 pi. So I'm just going to draw my coordinate axis. All students take calculus. Well, I don't know that I even need that. But when cosine is 0 is when x is 0. And, it's these multiples here. So this point, which is 0, 1. This point, which is 0, -1. And cosine, comma, x, comma, sine x. And so the angles that give us these answers are pi over 2. And this other one is from here over to there, 3 pi over 2. And just note to self, at this point, you should be getting things that are going to work on the coordinate axis. Now, that took me 24 minutes, so I just want to give you the rest of your time to work. I will be here before school on Monday. I'm kind of dedicating my time before school from 7:30 to 8:15 or whatever, that if you would like to come in and ask me questions, you sure can. My study hall is 4th hour. I will be leaving at noon, and you will have the quiz on Monday as well. And I may even email everybody just to remind you of that. So I'm going to give you the rest of the time to work on things, and I will let you get started.